All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. As you are coming in and logging into to the Zoom session on Canvas, you're going to notice we have warm-up number 16 on your screen. Only copy it, and you can do that on your own during your home play time, okay? Because we don't only have much time left for today because it's minimum. So you finish that on your, just copy it. And it reads, warm-up number 16 says simplify. Then we have 3y in parentheses plus 4x squared y minus 2, parentheses, open parentheses, times 2x y plus 1 minus y. For number 2, we have parentheses x squared plus 5 plus 6, close parentheses, minus, open parentheses, negative 3x squared plus x minus 1. 3, it says solve. Then we have negative 25 greater than or equal to negative 5x plus 5 and negative 35. And for number 4, identify the greatest common factor of 18, 24, and 30. Go ahead and copy that. I'll give you 2 minutes, and then we'll move on. Copy and go. All right, now that you copied that, let's copy the agenda for today. Here we go. Agenda for today was warm-up number 16, multiplying polynomials. Today we're moving on to binomial theorem. Your home play pages for today is page 303 and 304, evens only. Copy that. All right, so now that you copy the agenda, for those of you that somehow you can't get a hold of your book, there's a code WUZQE, and that is for Nearpod. And in there I included the 2 pages for tonight's home play in PDF format. So please copy that. Now, the reason I'm bringing this up because earlier somebody said, Mr. Q, on last night's home play, I think we turned into 89 or something like that together. Come on, well, good thing you copied the code, right? Like that you can go to the page right there in Nearpod and just get the problems. Yes, okay. All right, so WUZQE. All right, last night's home play was pages 285, numbers 3 and 4, 288, numbers 6 and 7, and 289, numbers 8 and 9. So we're not going to turn that in right now because we don't have a lot of time. This is what I want you to do, though. When you get home, right after lunch, take pictures of your home play, go to Canvas, go to the polynomials module, and in there, you're going to see the assignment. This one, you click on it and submit your pictures in there. You got it? Yes? So tell your neighbor what to do with this, please. Yes, take pictures and submit on Canvas. And please, no selfies. Last year I had students doing this. I can't see it from that far. Just take a picture of your work. Please, pretty please. All right, let's go. Tonight's home play once again, 303, 304, evens only. Let's move on. Our objective for today, I can multiply polynomials. So just FYI, today is going to go super fast like this. Look, like that fast. So I know, right? I'm telling you. Yeah, you wouldn't like to play me on the basketball court. I'll break your ankles, both. All right, so we don't need a Frere model because we know what polynomials are already, and we need to move on. We know that they are monomials or some are different than monomials, example, non-examples, and a hashtag. You have that, yes? All right, so write your utensils down, look up to the screen. Right now it should be blank. So I'm gonna start off by doing an introduction to today's theorem. Today we're gonna be covering something called the binomial theorem. So in nature, guys, in nature, everything, including us, we have numbers and mathematics embedded in us. And I already kind of like talked a little bit into that. So look at these images on the screen. All these images, such as the cauliflower, that shell right there, and the other flower, all of them have patterns and they grow in patterns, and it's all mathematics. You're like, what? I know, right? So let me show you this shell in mathematical form. There it is. It grows in areas of squares, and it has a particular pattern. Well, guess what? That same pattern is embedded in our DNA. Look at our fingerprint. Our fingerprints have the same pattern. They grow in that way. You're like, Mr. Q, man, you're scaring me. I know, right? Everything involves numbers. Today, we're going to talk about something called the Pascal Triangle. Who's heard of that before? Pascal Triangle? Okay, good. Nobody raised their hand. Nobody's heard of Pascal? My goodness. All right, Pascal was a mathematician, and he, as well as Mr. Q, liked to observe things and make mathematical assertions or observations. So he observed that nature grows in a certain amount of numbers and patterns. And he came up with what we call a Pascal triangle. Look at your screen. And this is what the triangle looks like. He said, it always starts with 1, and then from there it keeps growing, and it has a pattern to grow. Let me show you that pattern. I'm going to put some animation to this, so focus on the screen. Here it goes. So you can know how to fill in the rest of the pyramid. Here it goes. Let me do that again. So that's what we call the Pascal triangle. Now, you're like, Mr. Q, what does that mean? Okay, so let me kind of like put it in this way. If you plant, let's say, a seed, here's a pot. And you put a little seed in there. There it is. Like my artwork, yeah? Pretty good? Yeah. Thank you, appreciate it. The way plants grow, let me blow your noodle. It starts with a stem, right? And then from there, it has 2 branches. You're like, what? Well, look, here's 1 stem, here's 1, here's 2 branches, and so on and so forth. You're like, what? I know, right? Yeah, I'm telling you, it's cool. So anyways, so if we look at it in that way, this triangle will continue growing, and that's how they grow. Same thing if you plant like a cactus, a nopal, you have the first part, then it goes into 2, and then one of them goes into 2, another one, and it just starts growing in that direction. So a way of writing this one would be as follows. 1, 1, 1. What is 1 plus 1? 2, and then you put 1s at the end. What is 1 plus 2? 3. 2 plus 1, 3, and then 1s at the end. What is 1 plus 3? 4. What is 3 plus 1? 4. What is 3 plus 3? 6, and then you put 1s at the end. This is how you build your Pascal triangle. Now, Pascal said, since this is the first stem or the first row, or what we start with, we're going to call that row 0, because that's our beginning row. But after that, we go to row 1, row 2, row 3, row 4, and so on and so forth. Now, a way to memorize how to write the rows, check this out. Notice that the 2 is in row 2. Notice that the 3 is in what? Row 3. Notice that the 4 is in row 4. And 1 is in row 1. And this one, we just started with a 1, which is row 0. Copy that, please. This one, not the hexagons. That'll take you forever. Just copy this. And as you're copying that, I want you to write me row 5. Row 5. I'll give you some time for that. Copy and go. All right. So you should be done by now, yes? Including row 5, yes? Okay, share your row 5 with your neighbor, see if they have the same thing. All right, let's see. Juliana, what'd you get for row 5? 1, 5, 10, 10, 5, 1. Hands if you got that. That is correct. Let's go. Since you're at it, find me row 6. 20 seconds. You're like, what? All right, we got it. All right, Miguel, what'd you get? Row 6. I'm sorry? Okay, I'll come back to you. Hurry up. All right, help him out, Lenny. What'd you get? 1, 6, 15, 20, 15, 6, 1. Hands if you got that. That is correct. So that's how the Pascal works, okay? So, Mr. Q, why are you showing this to us? Because today we're going to be multiplying binomials, and instead of multiplying the whole thing because it's a lot of work, we're going to use the Pascal Triangle to help us find the product a lot faster. All right, so here we go. Look at this next example. Don't copy it, please. Check this out. Look up. Before you give me answers, just to reiterate or to refreshing your memory, whenever you have a number such as 2 to the 0 exponent, any number to the 0 exponent is always 1. Once again, any number. Next, the other one. Any number to the first exponent is the number itself, which is 2. So with that said, check this out. This one's easy. X plus y to the 0 is 1. X plus y to the 1 is x plus y. Okay, that's easy. The next one is easy because I asked you to memorize the identity of this one. Is that correct? Which is x squared plus 2xy plus y squared. And you're like, oh, that's true. I needed to memorize those. Yes, it's only 3 of them right now. By now, you should have them memorized. Please. Look where we're going. If I asked you to find me the product of this one is to the 3rd power. That means x plus y times x plus y times x plus y. And we can do area model and then multiply this with distributive, whatever. But look at this one. X plus y times x plus y times x plus y times x plus y. It's a lot of work, isn't it? Now check this out. What if I said x plus y to the 6th power? That's a lot of work. So in order to save us that amount of work, today we're going to use the Pascal Triangle to show you how to use patterns to find the product with big binomials like that. So with that said, copy this next one, please. Example, Michael Jordan Q. And just write parentheses x minus y cubed. You don't have to worry about the instructions. You can watch those on YouTube later on. And it reads, find the product using the binomial theorem, then check by multiplying using any method. Today, for the sake of time, we're not going to do the checking because it involves multiplying it out completely again. But I just want to show you the pattern on how to find the product. Okay, here it goes. X minus y cubed. All right, writing utensils down, look up to the screen. Here we go. Writing utensils down, stay focused, please. Please, pretty please. I'm telling you, if you missed this part, you're probably gonna miss the whole thing. Here he goes. To get started, first, in order to use the Pascal triangle, by looking at this binomial that they gave us, we need to find out which row to use in the Pascal triangle. How do we do that, Mr. Q? By looking at the exponents. That is going to tell us which row to use. So that means I would build my Pascal triangle, and I would label row 0, row 1, row 2, row 3. That means I'm going to use 1, 3, 3, 1 as my row 3. How does that work, Mr. Q? Well, let me show you. I'm going to use this, and all of these from now on my product, they're going to be coefficients. What does that mean? The first number that multiplies the variable. So here we go. Writing utensils down, you're only paying attention. I'm going to start with the number 1. Okay. From there, I'm going to start with the first term, which is x to the 3rd power. From there, I'm going to go to the second term, but instead of writing to the 3rd power, that one I start to the 0 power. I'm done with the first one. I'm going to the next one, plus 3. Now look what's going to happen to x to the 3rd. Look what's going to happen to negative y. Let me go to the next one, which is plus 3. Look what's going to happen to x to the 2nd. Look what's going to happen to negative y to the 1st. And last but not least, my last coefficient is 1. Look what's going to happen to x to the 1st. And what happens to negative y to the 2nd. Copy that, please. All right, let's see where we're at again. We got started with x minus y to the 3rd power. They want us to multiply that, but we're going to use the Pascal triangle to write our product. How do we start? By checking out the exponent, and that's going to be the row that we're going to use. We write our Pascal triangle, and we use row 3, which is 1, 3, 3, 1. And we said that those numbers are known as what? Our coefficients. Hopefully you see them here, 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 and there. We start off by writing our first term to the 3rd power, that's x to the 3rd, and the second term times the 0 exponent. From there, we write our next coefficient, and then from there, the first term keeps going down from 2nd to 1st to 0. The second term increases from 0 to 1 to 2 to 3. All right, here goes the last part. Writing utensils down, look up to the screen. Here it goes. The last part, we always simplify. So pay attention to this part. Here we go. I'm going to start with the first term. What is negative y to the 0? 1. So I'm going to take 1 and multiply times 1. 1 times 1 is 1. 1 times x cubed is x cubed. Next, what is negative y to the 1st? Negative y. Okay, that became that. All right, so now we have a negative here and a positive here. What is positive times the negative is a negative. There is no number here, so I bring down the 3, the x squared, and the y. Next, this one, negative y to the 2nd. Negative y times negative y is positive y squared. That became that. Since all of them are positive, I'm going to write, bless you, 3x to the 1st and y to the 2nd. And last but not least, negative y times negative y times negative y. Negative times negative times negative is negative y cubed. All right. So therefore, negative times a positive is a negative. What is x to the 0? X to the 0 is 1. 1 times 1 is 1 times y cubed is y cubed. And this is our product. Copy that, please. All right. So by what we look at, it's just a matter of getting used to the pattern because one of them decreases, the other one increases. We need to use the coefficients using the Pascal Triangle. So let's see how you do with one. I'm going to give you a head start. Example, Shazam Q. I want you to multiply A minus B to the fourth power. And I'll leave that example up there so you guys can have it as a reference. And I'll give you some time for that. Copy and go. So for this one, which row are we going to use? Miguel. 4. And what are the coefficients? 1, 4, 6, 4, 1. Hands if you got that. That is correct. Okay. Okay. Now, for those of you that are still struggling setting this up, let me show you another way of setting it up. Hopefully that helps. Here we go. We know that these are what? Coefficients, yes? So watch what I'm going to do. 1, leave a space, plus 4, leave a space, plus 6, leave a space, plus 4, leave a space, and 1. Next, I start with my first term, which is a to the fourth power. That means in the next term, it becomes what? A to the third, a to the second, a to the first, a to the 0. The second term, we use negative b to the 0. So that means the next one is negative b to the first. That means the next one is negative b to the second, negative b to the third, and negative b to the fourth. Is that a little bit better? Yeah, for some of you? Yeah, okay. All right, let's simplify this. What is negative b to the 0? That is 1. 1 times 1 is 1 times a to the fourth is a to the fourth. Negative b to the first is negative b. That means negative times a positive is a negative. And then we got 4a cubed, and just bring down the b. Next, negative b squared is positive b squared, because negative times negative is a positive. And notice now all of them are positive, so it's plus 6a squared b squared. Next, negative times a negative, positive times a negative is a negative b cubed. Negative times a positive is a negative, so we bring down the 4, a to the first, b to the third. And last but not least, negative b to the fourth is negative times a negative times a negative times a negative. That's positive b to the fourth. That became that. Since all of them are positive, let's see, what is 1 times a to the 0 is what? 1. 1 times 1 is 1, so that leaves us with positive b to the fourth. All right, show me what things how come you are with that so far. Got some 5s, 4s, 5, 3s, 5, 4s, 4.5s. Okay. Yeah, we need more practice. Yeah. Okay. Let's do another one. So hopefully now you find a pattern as to how to set it up. You can either just go one term at a time, or you can do all the coefficients and term 1 and then decrease, and then term 2 and then increase. It's up to you whichever way you use it. All right, let's use a combination of variables and numbers. Copy this next one. Example 3. We got x minus 2 and all that to the third power. All right. So Ricardo, what row are we going to use? Third row. What are our coefficients? One, 3, 3, 1. How did he get there? He started with 1, 1, 1, 1, 2, 1, and then that's how we got to that. That's row 3. So these are our coefficients. So I'm going to use the last method that I showed you to go a little bit faster. I start with 1, leave a space, plus 3, leave a space, plus 3, leave a space, plus 1. Okay, next, I'm going to take the first term and I write x to the what? Third. And the second term and I write -2 to the 0. So I'm going to take the first term, which is x to the third. I'm going to write x to the second, x to the first, x to the 0. Next, -2 to the 0 is -2 to the first. From there, -2 to the second, and -2 to the third. All right, let's simplify. Yes, here we go. What is -2 to the 0, guys? 1, what is 1 times 1? 1 times x cubed is x cubed. Okay, do me a favor. Let me do the next term. Let me show you what needs to happen there. Write your utensils down, look up to the screen. Here it goes. -2, you're just paying attention. -2 to the first power is what? -2. What is negative times a positive? Negative, but now we have two numbers. So what is 2 times 3? 6, and bring down the x squared. Copy that, please. And that's how you're going to work these out that have numbers in them. You multiply the numbers, multiply the signs. Next, -2 squared is -2 times -2. It's +4. Since they're all positives, what is 4 times 3? 12, x to the first. And the last one, -2 cubed, that's -2 times -2 times -2, that's -8. Negative times a positive is negative. What is x to the 0? 1. 1 times 1 times 1 times 8, that's 8. And this is our product. Woo. All right. Let's see. Now with numbers, show me what famous outcomes you are with these. 5, 5 fours, 5 fours, 5 fours. Okay. Let's do one more. Here we go. Copy this one. Example. That's too easy. Copy this one. X plus 2 to the 4th. X plus 2 to the 4th. Example 3 super Q. And I'll let you do that one by yourself. I'll give you some time. Ready and go. All right, so which row and coefficients for that one? Valerie, go. Which row? 1, 4, 6, 4, 1. Hands if you got that. Yes, that's row 4. Yes. So I mean my coefficients are 1, leave a space, plus 4, leave a space, plus 6, leave a space, plus 4, leave a space, plus 1. My first term is x, and I'm going to write x to the 4th, then x to the 3rd, x to the 2nd, x to the 1st, x to the 0. My next term is +2, so in parentheses, 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. Hands if you got up to right there. Okay, good. Next, we got 2 to the 0 is 1. 1 times 1 is 1 times x to the 4th is x to the 4th. Okay. 2 to the 1st is 2. 2 times 4 is 8, so it's +8x cubed. 2 to the 2nd is 4. 4 times 6, that's +24x to the 2nd. 2 to the 3rd is 8. 8 times 4, that's +32x to the 1st. And 2 to the 4th is 16. 1 times x to the 0 is still 1. 1 times 1 times 16 is 16. And if you got that, let's go. Show me your fingers, how come you are with these. 10s, 5s, 4s, 5, 4s. Okay. Yeah, we got this. Yes? Yes, Mr. Q. All right, let's do one last one. Y'all ready? Here we go. Copy this one, example 3, or let's see. Where are we at? Oh, my bad. No, we're out of time. Sorry. Man, time flew when you're having math. Let's go. So once again, guys, your home play, make sure you get that done. And last night's on Canvas as soon as you get home, and work on it tonight because tomorrow we're moving on. Everyone, enjoy your home play. See you guys tomorrow. Bye.
Bye, guys.